M1.34, little review of some ratio concepts. For every 24 leaves there are 18 branches. Complete the table of equivalent ratios for the given situation. So ratio of 24 to 18, and I can see both of these are divisible by 6. 24 divided by 6 is 4, 18 divided by 6 is 3. So my ratio, written in simplest form or largest possible units, is a ratio of 4 to 3. So that tells me if I have 4 leaves, I have 3 branches. 3 times 3 is 9, 4 times 3 is 12, 3 times 5 is 15, 4 times 5 is 20, 4 times 8 is 32, 3 times 8 is 24, 3 times 10 is 30, and 4 times 10 is 40, and 4 times 9 is 36, and 3 times 9 is 27. Grab my eraser here and remove some of this so you can see the answer a little more clearly. Alright, looking at 1B. Going to be using the information from 1A to complete 1B. In particular, we are going to be using that 4 to 3 ratio right there. Write 2 equations showing the ratio relationship between the number of leaves and the number of branches. The ratio of leaves to branches is 4 to 3, which I can then turn into the fraction form. So the leaves are the branches times 4/3. And the branches to the leaves, wrong variable there, is 3 to 4, which is 3/4. So the branches are the leaves times 3/4. That takes care of question 1A and 1B. Looking at number 2, 28 frogs, 16 ducks, 8 geese in the pond. Table of equivalent ratios to show the ratio of, got a typo there, should be frogs to geese. Use the table to select the ratios that are equivalent to the ratio of frogs to geese. I'll fix that before we print the hard copies. Alright, so I have frogs to geese, 28 to 8. Both of these are divisible by 4. 8 divided by 4 is 2. 28 divided by 4 is 7. So I have frogs and geese. And for the frogs, I'm counting by 7s. 7, 14, 21, 28, 35, 42, 49, 56, and 63. For the geese, I'm counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, and 18. Now that I have my table of frogs and geese, I can come take a look and see which of these ratios are equivalent to the ratio of frogs to geese. This first one says 2 to 7, but I'm looking for 2 frogs going with 7 geese. That is the opposite of what is happening in this column. That is written in the wrong order. I also can look and say that I have more frogs than geese, so I should have ratios that have more frogs than geese. So looking, I can see that that one is also not going to work. These others I need to check and just make sure that they're actually correct. So going to my table and looking for 28 frogs, do I have 28 frogs with 8 geese? The answer is yes, I do. Those go. Looking for 7 frogs, again back in this spot, 2 geese, and that works. 49 frogs out here, going with 14 geese, 49 frogs with 14 geese. So I have 3 ratios over here that are equivalent to the ratio of frogs to geese. For $6.23 you can purchase 89 ounces of orange juice. What is the price per ounce of the orange juice? So we're doing a unit price here. So I will have dollars per ounces, and I have $6.23 per 89 ounces. And if I'm doing dollars per ounces, I need to have 1 ounce instead of 89. So I will divide by 89, and I will divide by 89. And in my classroom, this is a rate question, so we get out our calculator. 6 23/100 divided by 89. And now I need to interpret the answer, and this means that it is 7 cents per ounce. All right, looking at number 4. What is 25% of 72? Draw and label a double number line to find your answer. Double number line. I have 100% on the percent line. On the number line, I have to decide, is 72 a part, a percent, or a whole? And I'm looking for a percent of 72, so 72 must be the whole. And I am looking for 25%. And we've been practicing counting by 10s, 20s, and 25s, so I know that I can count by 25s, 25, 50, 75. If I draw my lines through on my double number line, I can now see that 72 has been divided by 1, 2, 3, 4. 72 divided by 4 is 18, so I'm counting by 18s. So 18, 18 doubled, 36, 36 and 18, 36 plus 10 is 46, plus 8 more makes 54. 54 plus 18, add 10, 64 plus 8 is 72. I can see that 18 is 25% of 72. And that concludes this little ratio review.